Vectors is one of the most confusing units in the AHL syllabus, so we are making this video to try to better understand vectors through real-world applications. We'll explore how vectors help us describe projectile motion using calculus and vectors. Position in 2D space is described using a vector function, where x of t and y of t describe horizontal and vertical motion.
Velocity and acceleration are both derivatives of the position or displacement, where velocity is the first derivative and acceleration is the second.
Let's apply this to a real example to compare two soccer kicks. Anna kicks a ball at 20 meters per second at an angle of 40 degrees. We can break this down into horizontal and vertical components using trigonometry. Now, using these values, we can write the position equation for the ball's motion over time. To find out when the ball hits the ground, we set y of t equal to 0 and then we solve for t.
We can determine useful information like the maximum height by setting the derivative of y with respect to t as 0 and solving for t. We can also calculate how far the ball travels before hitting the ground by finding x at that final time.
We can do the same for Janine's kick to compare the two.
This method is widely used in physics, engineering, and even space exploration to calculate trajectories.
To summarize, vector-valued functions help us describe motion in two dimensions. By differentiating, we can analyze velocity and acceleration, which are crucial for understanding projectile motion. Try applying this method to other scenarios like a basketball shot or a long jump. Thanks for watching!